Intro for myself. This is Kumar here. I would be the administrator. I would be the trainer for your administration course, including your the entire course, which contents which Daniel has showed right now. So, and before starting on, let me also share my screen and also bring up the. Can you guys see my screen? All right. So this is where this is the content. You guys can see my screen, right? We talk about. This is the content, entire content. We quickly do a quick. This course content is about 40-hour duration is what we're targeting for. Now, this has a quick intro. We actually talk about big data introduction, and then we walk you through the introduction stuff, and then we move on to installation part. That's where the Hadoop administration is. We give a quick. We give demos on where we do demos and then introduce you to how you install Hadoop packages from different vendors. So primarily we have major vendors from Cloudera and Hortonworks. So we have instructions to show you how you can set up the how you can set up your clusters, like a simple 3-node cluster or 4-node cluster for your testing purposes, and we'll also show you various aspects of the administration. So this will give you a quick, this will give you a more hands-on approach on how you can manage, and going forward when you actually start working in your production environments, right? What will happen? You would definitely be working. You would not be working with an individual tool, right? So you might definitely need to know some of the industry leading tools, and that would be a Cloudera Manager or CDH or Hortonworks HTTP. So Hortonworks, I will explain this terminology as we go through the session. Okay. Now, another important, first of all, we do Hadoop administration, then initial 5-6 classes we talk about administration, and then we'll jump on to development part where we explain to you the various ecosystem projects. Some of them is a Scoop, then we talk about Pig, and then we talk about Spark in detail, and we also introduce you to Hive. Okay, like these are the various tools where typically you can these are the ecosystem projects. Well, I'll explain in this session what are these ecosystem projects and all. And these will be covered as part of your development aspect. Now that's surrounding your that is revolved around your core Hadoop and your administration and development part. Then the third aspect is that we cover here is the NoSQL databases. Now the NoSQL databases is becoming more and more utilized, or more and more. A lot of companies are adopting now towards moving towards NoSQL databases. So that's one of the important reasons why we thought is we will include NoSQL also, and we'll talk about Cassandra and MongoDB. Primarily, we'll give you an hands-on experience on Cassandra and MongoDB, and I think Cassandra is one which is widely used, and MongoDB is also being picked up right now. And all these installations that we do right now would typically be done on a cloud setup on the Amazon AWS instance. Okay, so finally we talked about Solar. Solar is something which is an indexing tool, which will this is one of the applications. This is also picking up widely right now, and a lot of companies are looking for expertise on Solar. So Solar in effect will be using Lucene, which is a search engine. So it's the core of your Solar application would be Lucene. So that's on the stuff that's on the how the course is modeled around. Okay, the entire course content. So if you see in the industry or outside, people give you they talk about administration only, they talk about development only, or they talk about NoSQL database only. But the reason why we combine these three components together is because once you're done with this, you can choose your path, whichever path you would be interested to go towards. Either you want to be an administrator, you can do more hands-on towards administration and explore on the administration skills. And if you want to go towards your development stuff, yes, you can work more towards development. And if you're interested, or if you're a database guy, you're a database background, you can certainly look at improving your career, or looking for growth on your on the database towards your NoSQL database. Okay, so that's the core reason. The core idea of us is to make sure we combine these three together and provide you as a package, or give you hands-on or experience on these three components: the development part, the administration part, and the NoSQL databases. And once you're done with this, right, if you're thorough, if you have a very good experience, you can also look for an architecture role where all these three components will definitely be helping you towards building up a nice solution. Or if you want to come up with a POC, well, your knowledge or your your skills on the three different components will definitely help you. So that's about the course outline. Any questions so far about the course content or how this is structured?
Will we be doing any real life examples of how it is in the real world with Hadoop and stuff like that?
Yes, real world examples. Basically, the setup is done on a 3-node cluster, so 3 nodes on maybe 3 or 4 nodes, and yes, we would typically be explaining you how the setup is done, and that's the first thing. And as for the real life examples, yes, we will be executing you the queries. We'll be telling you what are the real world queries would be like, and we'll walk you through those. So 1 or 2 examples will be given, and you can come up with your own queries, and you can also explore on that. Does it answer your question?
Just wanted to know if it was like more project based, because a lot of companies will ask you, oh, how did you use it, scenarios and stuff like that, and any troubleshooting techniques, and they always ask questions like this, right?
Yes, Imran, that's right. So yeah, we provide you POC. So there are some couple of POCs written by our architects. So those POCs are being completely used by some of the companies, right? So it's a kind of a framework which was rolled out to some of the major MNCs. So that POC, we can give you that, and we can also explain to you how that POC is set up. And yes, it will give you a real world example which you can showcase as your project that you have worked on. Okay, so once you're done with that, I'm pretty confident that you should be able to answer any questions, and if you get real-time experience. So the approach here would be 50% of the practicals. You need to spend more time on the practicals. The more time you spend on the practicals, the more knowledge you'll grasp, or the more information you'll get. Okay, so some of the troubleshooting steps, yes, we can definitely help you, but some of the things is you need to do more practicals, and as you do some of the practicals, some of the errors that you get, right? So person A, person B, person 3 people working on different setups. So each of them would be getting different kinds of errors, and that's where the blog comes into picture. If you can share all your troubleshooting steps at one place, and that's one of the important reasons we thought we'll share it together. So all 3 people come together and share your troubleshooting or your issues that you're encountering, so people will get to know what are the kind of issues you have come across, and what will be the solution. So that could definitely help you. And yes, troubleshooting is one of the important things people will ask, and the more hands-on experience you do, the more troubleshooting you get, and that's what we can showcase. All right, so some of the questions coming on the chat window are any prerequisites? No, there are no prerequisites required. Basically, this is a Java-based application. No prerequisites are required as of now, I would say, for a Hadoop administrator also. Only thing is it is entirely a Linux-based application. Okay, so entirely deployed on Linux. But having said that, I would also need to point out that with version 2, you can also deploy it on Windows. Okay, so there is something called HD Insight, which is out of the scope of this course, but since you're asking, I just want to bring it up. So Microsoft, in partnership with Hortonworks, has come up with a solution, HD Insight, which can be deployed on on a Windows machine or a Windows cluster. But that's something which I think which is not widely picked up right now. That is some solution which Microsoft is really pushing hard. But as of now, the current industry or the current the companies that are using are primarily surrounded around or revolved around Linux environments. So I mean, I would not say you don't need any Linux skills, but basics of Linux is what would be required. Understanding how operating system is set up and how the disk is architectured or how the disk is set up. So basics, very core basics. The reason because some of the commands that you execute on Hadoop, right? So I mean, let's say Hadoop FSLS or HDFS FSLS. So ls is a command which you can typically run on your Linux machine. Right, so some of these commands which you basically run on your Hadoop, so those are the commands which are very much similar to your Linux. Okay, so that's on the Linux side. And the question is, I don't have any coding background. I'm from telecommunications background. Yes, no, absolutely no issues on that part. Java coding is also not required for this. Basically, if you don't have any coding experience, yes, even then you can start working on it. Okay, so how you may ask, the reason that being, like say here you can talk about some of the ecosystem projects, right? The Scoop, the Pig, and you're talking about Hive. So these are the different ecosystem projects. So if you're a database administrator, you would typically be, I mean, you're an expert on writing your SQL queries, right? So Hive is something which will provide you high query language. So high query language is very much similar to your SQL, right? So the syntax and the way you execute them is almost equal to your SQL language. So if you are an expert writing SQL queries, yes, you can use the same syntax, the same command or the same query run on your HiveQL also, okay, on your Hive. So that is where you talk about ecosystem projects, okay, where even though you don't have a coding knowledge or you don't need to know how your Hadoop is set up, your cluster is set up, a database administrator can run, a Linux administrator can run. So say for example a Linux administrator might be an expert in writing shell scripting. So what he can do is he can simply leverage the Python skills and write a Python code where the Python script can still run on your Hadoop cluster. Okay, so when he runs a Python script that he runs on Hadoop cluster, what will happen is it will in turn convert into a MapReduce program, right? So a MapReduce program is nothing but your Java program, right? So map is one program, reduce is one program. So it's again a Java program which will be running on your cluster. But basically what you have done, you have invoked a Python script, or you have invoked a Hive query language, right? So in turn it will internally convert into a MapReduce or a Java program, but the top level you don't need to worry about internals, right? So how this is achieved, there is something called streaming API. So any person who is from a non-Java background, so if you set up streaming API on your Hadoop cluster, a guy with .NET background, a guy with let's say C++ or C guy, I mean a person who's very good at writing C programs, or a person who's good at writing Python programs can still be able to execute programs which will leverage your MapReduce architecture.
Hey, Kumar.
Yes.
Yeah, this is Tanmant here, Kumar. As you mentioned it, NoSQL, one of the thing is MongoDB and Cassandra. Is MongoDB and Cassandra both are different databases, right?
That's right. Different databases, they revolve around, different, you can say, let's say HBase. HBase is a call-oriented database. So MongoDB and Cassandra cater to different kinds of databases. But in effect, what will happen is these two would be running or leveraging your HDFS. Okay. So from different vendors, and MongoDB is something, I think it's a little bit expensive, and Cassandra is what widely used.
So you mean to say, like, you're not going to teach here MongoDB admin or Cassandra admin, just you're going to explain how you are going to use NoSQL. That's it, right?
No. We would definitely be covering Cassandra. We go in depth on Cassandra and MongoDB. So we cover the concepts. We cover the differences. When we also do a setup, and how you set up and what are the primary differences, and we'll also give you a real world example on that.
No, what I'm saying is, like, you're not going to teach here MongoDB or MongoDB DBA or Cassandra DBA part, right? Just you're going to explain how we are going to utilize with NoSQL. That's it, right?
Kind of both, I would say. We will teach you on the core concepts and also on the admin side how you set up and how you can use it. Okay, so when we say how you use it, there are some concepts which comes up, and those will be explained to you during this duration of the course.
But do you think is a sufficient time, as you have a lot of things you're going to cover, NoSQL and Hadoop admin and Hadoop develop? So do you think is the 40 hours is sufficient to learn everything, or so the daily?
Yes. Absolutely, 40 hours is definitely sufficient, and in case if there are anything that is not able to cover, yes, we will definitely be taking additional time to cover those topics. Okay, so we'll make sure you understand, and whatever is being showcased here, we'll make sure we cover those topics, and yeah, we'll in case those are in the 40 hours, if you feel is not sufficient, we will definitely be expanding on that, and you can always come back to us with any questions, any concerns, and we will definitely be able to assist you.
Okay, Kumar, can you hear me?
Oh, yes, Anthony.
Let me elaborate that answer for you. Now, this training is, a practical-oriented training. Now, if you go and see any administration course, most of the duration are, a majority of the, the courses will be 15 hours, right? So, what we are trying to cover here is the administrative, or rather the administrative aspects of the operational tools that that was being that was being raised here just before, which are primarily MongoDB and Cassandra. Now, what will happen in the class is we will not sit and talk about Cassandra and MongoDB. That's not what we're going to do. We are going to work with MongoDB and Cassandra. There is a difference between teaching MongoDB and Cassandra and just putting up slides, going through it, trying to understand what is MongoDB, what is Cassandra, and there is a lot of difference between actually doing a practical how do I put it, practical demonstration of that particular tool. Whatever you need to read, what MongoDB is, what Cassandra is, whatever you need to read, you have to read offline using the materials that we provide in the class.
Yes. Yeah. Okay. Thank you. So, how about the Hadoop admin? The same thing you're going to do the same thing with the Hadoop admin also?
Yes. Everything will be covered with practical, with a live practical demonstration with a live use case. Okay. Now, definitions, explanations, whatever are certain things that you can read, we will want you to read it offline, because there is no point reading something which is already available there, right? Rather than doing that, we will try to focus on practical implementation of each and every tool, or rather product, which are being highlighted on the course here, and at the same time practical implementation in terms of administration or development.
So the lab is 24 hours available, or like how it will work for the lab?
The lab is, I don't think that's 24 hours available, because if we keep it open for 24 hours, that's gonna that would be like we would end up paying about $1,000 per day. There will be certain specific hours when it will be open according to requests at the same time. That's something we can discuss towards the end of the demo. I think Daniel will be able to provide more insight into how the instances will be made available for you and how long it remains open on a daily basis.
Okay, but the 40 hours is the every day you're going to conduct the class, or the only weekends you're going to cover the class?
It's the schedule. I think it looks Thursday through Sunday right now, or Friday through Sunday. So 40 hours will be split across Friday through Sunday every week.
How many weeks this effort? 4 weeks or 6 weeks?
We're looking at about 5 to 6 weeks.
Okay.
Yeah. Weekday batches get over, they get over in about a week's time. I'm sorry, in about 4 weeks' time, because we're able to cover at least 10 hours a week. Weekend sessions, they generally prolong a little bit because, the number of days and hours are a little bit reduced.
Do you have any weekday classes, or do you have only weekend classes?
We have weekday and weekend classes. There is always parallel classes running throughout the week, throughout the month.
Okay, the weekday classes, how many hours every day you are going to teach?
2 hours daily.
2 hours daily.
Yeah.
On the morning or the Eastern Standing Time, or specific, or how it will work?
Evening Eastern Time. Evening Eastern Time. What we have observed is anyone and everyone who's looking for Hadoop training, they are all working. So, morning time is generally not feasible for someone who works. I'm assuming you work as well. So, morning time may not be quite feasible.
Yeah, that's why I'm asking. Yeah.
Yeah. Okay. All right. So let's discuss this, schedule and the others, after the trainer has done his technical demonstration. In between the technical demonstration, let's keep it strictly technical. Once we're done with that, I will talk to you guys about placement, about logistics. That's where, we can discuss about all of this. Is that fine? Right. Okay. And RK, how many hands-on projects are you planning over 40 hours? Now, the project is not, something that you'll be doing throughout your class. If we keep doing that, the class will go on for about 200, 300 hours. Okay. So there will be one project which will be done live in the class, 3 more which will be outside of the class. Okay, instructions, support will be available, and we would expect you to finish it off, outside of the classroom. Okay, I will share those details, once we are done with the technical demonstration of Kumar. Okay, logistics, any other arrangement, be it schedule, be it placement, everything else, I will, discuss all of this in details once we are done with Kumar's. Okay. All right. Sorry, Kumar, for interrupting. Carry on. I'll take it over after you're done. Okay.
Right. Thanks, Anthony.
No problem.
All right. So for the part of this demo, what I've done is I have split into three parts. One is a quick intro, then we'll do a quick demo, and then we talk about why Hadoop. I think most of these I think some of the questions have been answered already. So typically this is what we actually do. So as coming to the demo part, the demos we'll do in a short while, maybe just for 10-15 minutes. I'll spend some time on the slides that we do right now, and we'll talk about what is big data, right? So most of you might be knowing, you already know, you already have read, and you have some background knowledge on what big data is and why we are sitting right now here. So we'll quickly walk you to the big data. So what big data is? So big data is something which has been available for a long time, and the data has been there. Okay, now the reason you guys are sitting here is because current industry is looking at solutions on how to handle this data, right? As the data keeps on growing, increasing on a day-to-day basis, so you need to look at solutions on how you handle this data. It's not that data is not there. It's not that data, big data is something which we are not talking right now, right? It's been, the big data has been, the data has been there for quite some time, and over a period of time, the amount of data that gets generated has become so large and complex that you need to look at some solutions, or you need to look at ways to handle this data. So that's what I mean. If you logically talk about, as a textbook definition, if you say big data is a collection of data sets, right, so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing systems. Right, so this data has been there for some time. Now the data is being handled, but what's happening is in the last 15 to 20 years, from starting about way back in about 2000, 2001 and 2, where your internet started exploding, right? So where your internet usage started, more and more people started using internet, the data explosion has started, right? So right now, every 2 years, the amount of data doubles, and I think in the last 1 year or the last 2 years, 90% of the data is generated compared to the last entire duration what we are talking about. So the data is increasing, right? So data is increasing. Now we'll see what are different kinds of data and what are the characteristics of the data, right? So typically. Somebody has a question, guys? Okay, perfect. So guys, if you have any question, I'll just give a minute where we can hold on, and or if you have any question, please raise a hand or type into the chat window, okay, so that I can try to address your questions. Now, we're talking about big data. So big data is any data that has been there for a while. Now, if you see, I mean, as an example, I can give you an Excel spreadsheets, right? So initially you have Excel spreadsheets. Now people started using Excel spreadsheets and they started uploading data into Excel. Now, as the Excel spreadsheets have become more and more, how do you manage those many spreadsheets, right? So initially first spreadsheet, yes, when it initially launched, right, it was really good to start working on Excel. But as the number of data, as the amount of data that you are loading into Excel has grown, it becomes more complex, right? It becomes more complex. How do you manage a number of hundreds of Excel spreadsheets, and how do you gather the data within all this? So that's where we talk about big data, where the current systems, it becomes difficult to process using on-hand database tools or your traditional processing tools. Now, some of the important core characteristics, right? We talked about the core characteristics. You have already seen about this. The 3 V's is what we talk: the volume, the velocity, and the variety of the data. Now, we talked about big data. Now, what are the characteristics that define your big data? The 3 characteristics would be the volume, huge amount of data coming inside your applications. Take, for example, Facebook as an example. So day in and day out, people log into Facebook and upload so much content, right? You put your text messages, you put your audio files, you put your image files, you put your video files. So much of data coming into your Facebook account. So just imagine huge amount of data, and let's say millions of people logging in every day. Even if one person uploads about 10 MB of data, just imagine the amount of data Facebook has to handle. So that's the volume of data we are talking about. Huge amount of data, and as this amount of data is becoming so much bigger, you need to look at ways to store it, right? So ways to store it in the sense, you need to store the data in a cheaper storage devices. So that's where huge amount of data is there. So volume is what one of the primary characteristic of your data. Now the second one is the variety of the data. Now historically we talked about, we've seen only RDBMS, right? Historically the data is being stored on your traditional database, or you can say your database systems. And all this data is what? All your data is your structured data, where you have data, or you can say the information that you store onto your DBMS is typically or primarily is adhering to your ACID properties, your integrity rules and all. Now here we talk about unstructured data. So structured data is what we can load into RDBMS. So what about unstructured data? Now look at the internet log files, right? So if you say any e-commerce site, if people log into an e-commerce site, okay, log into an account and start browsing through it, and they might purchase or they may not purchase some items, right? They just log out. So what is happening is this e-commerce site is not discarding that information. Whatever you have logged into an e-commerce site, okay, whichever site you logged in, they're actually capturing the information, capturing the data to see what is that you have done. I mean, to see what exactly, I mean, what product you have, what product you are interested in, what is that search you made, and what are the pages you have browsed on, right? So this is all log files, right? This is all your log files is all captured. That is one kind of a data. Now you see, if you're if you talk about weather prediction, you get huge amount of data, hundreds of GBs of data comes in, so through satellite imagery, and that data, using that analysis they do, right? So this is a different kind of data. Now take the example of Facebook also, Facebook only, where you talk about text file, you talk about audio files, video files, your JPGs, your images. So different kinds of data is being loaded onto your cluster, or you can say loaded onto your application. So that would be the second core important characteristic, and that is variety of the data. Now, third one is the velocity of the data. The velocity of the data is how fast the data is coming in. Right? Say, take for example Twitter as an example, and if one famous star is trying to put a tweet, that tweet keeps on. I mean, so many followers will retweet it, right? And also the amount of data coming inside. So anytime you have a doubt, apply these 3 V's and see on the data, apply these 3 V's on the data that is available, and that will tell you whether you need to go for a big data solution or not. So the volume of the data, the variety of the data, and the velocity of the data. Apply these 3 V's for the data that you have, and that will tell you whether you need to look at a solution on to handle this big data. Right. So if the volume is low, yes, your traditional database systems will definitely handle it. Right. So you run a query on your traditional RDBMS, or you run a query on your RDBMS machine. Your query, your Oracle SQL query, it will come out. I mean, you will get the output in a fraction of milliseconds. Right. So it's very, very faster. Now, you increase the amount of data, your RDBMS will slow down, the performance will slow down, because it needs to look at so many indexes. So many other parameters it needs to look at. And as the amount of data is increasing, your performance of your RDBMS might slow down. So that's where you need to look at other solution where the performance is not impacted, and you would still be able to run the same query on the same data set or a huge data set and get the output at a shorter time frame. Okay, so these are the 3 core characteristics we talked about. Not only these 3, there are other V's also. The value, right? What is a value? Value is something where, why are we doing this, capturing this data? Why a company is interested to capture this data and do some analysis? The reason, because the future forecast, right? There are some hidden information on the data that is being captured. Take for example the e-commerce site. E-commerce site gathers so much information. Why do they gather that information? The reason, because using this information, what all the data they have captured, they will come at some certain conclusions that the people in this region would be interested in this product, or people who have bought a particular product have also purchased a second item or a similar item. That's where you see the recommendation, right? So if you log into an e-commerce site and browse for a particular application, or say, a particular item, like say a mobile phone or a camera, what will you see is at the bottom, you will also see a recommendation for you saying that people who have bought this camera have also bought an additional lens. Okay, at most times you might be falling into the trap, or I would say you would go with a suggestion and you might purchase an additional lens. So what e-commerce site has done, in effect, if instead of selling one item, they have given you 2 items, right? You have purchased 2 items. That means the revenue is increasing, which was supposed to increase over maybe next quarter. They have increased the revenue at this point of time and during this quarter. Okay, so that's what we talk about entire big data. Why we talk about big data, what big data is. Huge amount of data where your traditional systems are not able to hold it, and you need to look at solutions on to capture this data and process this data, right? So 2 parts here. One is your capturing the data, the second one is processing the data. So a solution is being provided. That solution is nothing but Hadoop. So we'll talk in the next couple of slides what that is. So any questions so far, guys? So RK is asking, somehow I speed up relational database, then there is no need for data. Well, that question, yes, RK. See, like say, take an example of say you have about 500 GB of data on your RDBMS, you would get an output in about fraction of seconds, right? Now, say I mean, we are looking at Hadoop as a solution. Yes, run the same query on the data set that you have using Hadoop. Now, your output might be getting in about 5 minutes or 10 minutes. Yes, when the data set is low, yes, I mean it is your RDBMS is faster. Now increase your RDBMS, right? Your RDBMS data to about 1 terabyte or say 2 terabytes. Now the speed of your query execution will slow down. Earlier on your 500 GB of data, your query is coming very fast. Now how much performance speed up you can do, right? So I mean, though you put so many indexing, as the amount of data is increasing, right, you're obviously at some point of time your RDBMS, right, your database will slow down. Now increase this data to 2 terabytes. Your query, like say earlier it was coming on a 500 GB data set, the query is responding maybe in a few fraction of seconds. Now increase this, double this, triple this, or multiply by 4 times. This performance slows down a little bit. Okay. Now you might get this output in about a minute or two. Now the same data set, 1 terabyte of data, you run on a 100 node cluster, you would get the output in 10 minutes. So even if it's 500 GB of data, you're getting the output in 10 minutes. Now even if it's a 2 terabyte of data, you're getting the output in 10 minutes. Now increase the same data set by about, let's say, 1 petabyte. Well, your RDBMS may not hold it. 1 petabyte of data, just imagine how much amount of money you need to spend for the 1 petabyte of data, right? So if you look at that aspect, on the RDBMS scale, you need to look for a bigger box. That means you need to purchase, you need to invest additional amount, and you need to purchase a license and also the support for the additional server. So this previous one, okay, the previous data, that the previous box or the previous server may not be holding it, right? I mean, you need to discard it, or you may have to use it for a, let's say, for a different for a lower environment. So I mean, the comparison is what we'll talk about during this duration of the course. So I mean, it's a kind of a comparison in the sense, apply big data or apply Hadoop as a solution only when you have a huge data set. Yes, I agree. If it's a less data set, your RDBMS will work. Okay, don't look at. So that's where we talked about the characteristics, right? The volume. The volume is one of the important factor. So as there is a huge amount of data, then only you go for Hadoop cluster or Hadoop as a solution. Okay. Now when you talk about Hadoop as a solution, okay, so I mean you are looking at cheaper alternatives, right? Cheaper alternatives. Plus, the Hadoop will provide you a solution where you can store the data and also do the processing part. Okay, so we'll come to that, RK, during this course. Now, another question from RK is, does big data need any schema like relational data? No, big data, the NoSQL, that's what we talk about, NoSQL databases. It's all schemaless database, right? Like your HBase, your Cassandra, your MongoDB are all schemaless databases, right? So you don't need to have any schema, and that's one of the advantage here. Now, if you talk about your RDBMS, you have a specific schema. Now you want to implement, say application is there, application A, you want to add a new field, or say a new column needs to be added. What you have to do, you need to obviously take the backup of the data, create a new schema, and upload all this data into the new table. But with NoSQL database, you can simply add a column there. Like say, take for example HBase. So you want to add one more column? Yes, you can add one more column, and from then on, it's a column, because HBase is a column-oriented database, so you can still populate the data, but this is not applicable with your RDBMS, right? So there are a lot of things. Well, when we talk about comparison, we'll get to that part. Okay, so as of now, NoSQL database is a completely NoSQL. Okay, it's a schema-less database, so you don't have any schema there. You can simply copy any data into your NoSQL database. You can simply say copy any data while putting into your HBase cluster or your Cassandra or your MongoDB. All right. So one of the examples of previously, I mean, why we talked about again on big data as a solution, or not a big data as a solution, Hadoop as a solution is how do we solve? I mean, just you need to understand as a quick background on how traditionally data is being handled. Right. So now today we are talking about Hadoop. Now, but it is not that the data was not there earlier. Yes, the data was there earlier. So how was it being handled? Right. So you see here something called, I mean, you are talking about storage servers. Right. Every data that you capture needs to go and reside in some location, and that is nothing but your storage server. So you purchase, your organization and enterprise will invest in millions of dollars to purchase a single storage server, which is very, very expensive. Right. Now you invest in multiple storage servers. Combine these storage together, you will get a filer. Okay. Now what is a filer? Filer is something which is a combination of like you say a storage server, and this storage server can be shared across multiple servers, right? So you are creating one layer of data, one layer of storage data, which is a combination of all these three servers together. That would be nothing but your SAN, or you call it as a storage area network. Now you would be hearing about terminology like NAS, SAN, or filer. So all this would be the same. Okay, it's the same storage. Right, like say if you want to purchase, your company is investing, like say you would say about millions of dollars to purchase a single storage server, right? So first thing is you capture the data and store it, right? So that storage is where is happening. It is on your filer. Filer is nothing but your storage network, or you can say storage area. Right. So these concepts, as we go through the session, you will get to know. Okay. For now, don't worry too much about it. Just think about, if you are new to these concepts, just think that this is a layer of network, or you can say a layer on top, which is made up of individual capacities of different computers. Okay. Or three different computers. The disk space of all these three combined together, you will have a storage layer here. Now, the reason I put this diagram here is because I want you to understand how the data was being handled previously, right? So previously the data was captured, stored onto one storage location, and you will have a distributed systems, right? So these distributed systems, what will happen is there will be an application server. An application server here, your application would be running on multiple different application machines, or different servers, individual servers. So this application will come and do the processing or do the work on this whatever data you have stored, right? Now when I say the application will come here, it's the other way around. You need to take the data from here to the application server, okay, do the processing here and send back the results here. Okay. Now say 10 people, okay, like let's say one person completing a job in 10 minutes. Now 10 people contributing to the same job, so your job will be completed in about 1 minute, right? So this is the same principle applied here. So you have a data, huge data. Let's have multiple people work on that data. Okay, chunk it. Okay, I mean split it into multiple tasks and provide each of the application server a simple task. So a simple data set. Now say if it's a 10 terabyte of data, this application server will get about 1 terabyte of data. Now application server A works on 1 terabyte of data and gives the results here. Now application server B works on 1 terabyte and gives back the results here. Now application C takes 1 terabyte of data and gives the results here. Now you have two problems here. The first thing is, when you talk about transferring the data, 1 terabyte of data from your storage place to the application server, you need to carry that here. Okay, you are taking the data to the processing, and when the process is done, and once the process is done, the same amount of data, or a limited amount of data, will come back and sit here. Right? It will sit onto your storage layer. Now the problem here is, when you are transferring the data, so much of network bandwidth is occupied. Now network is expensive, your network bandwidth is expensive, so you are occupying so much of network bandwidth, and while this transfer is happening, your application server is sitting idle, your processor is idle, right? Your CPU resources are idle, and it is just waiting for the data to come in. right? So let's say 1 terabyte of data would require about, let's say, 15 to 20 or 20 minutes to transfer 1 terabyte of data. Now for this 20 minutes, this app server is sitting idle. Just imagine how many application servers are here, and those many application servers are all sitting idle. So the problem here is you're taking the data to the processing, right? So now we need to look at a solution where you can take the processing to the data, right? You don't want to keep on this transfer happening. The data does not need to be transferred on the network. What you need to look at is you need to look at a solution where you take the processing to where the data is residing on. Okay, take the processing to where the data is residing, and you can do the processing on the same place and put the output on the same storage area, right? So on the same storage location. So that's where we talk about Hadoop as a solution, where you talk about here with traditional distributed systems, you're taking the data to the processing. With your Hadoop as a solution, you're taking the processing to the data, where the data is residing in. Okay, so you have in effect eliminated the additional network bandwidth, and also you have in effect eliminated the need for application server to be idle, right? Your application server is never idle in this case. The moment the data comes into your server, your application server will be processing it. Okay, that's what your Hadoop provides a solution there. So we'll talk about that in the next couple of slides. So this is a problem I was explaining, right? Distributed systems do a good job at distributing the workload, but the data still must get to the CPU. Now, if you're talking about 1 GB or 100 GB of data, okay, and this filer and NAS, don't worry about these concepts, okay? Just imagine this as a storage, okay? And NAS filer, you can think it of as a storage. Now, on a 1 GB network, it would take about 16 minutes, and for this 16 minutes, okay, where we're talking about 100 GB of data being transferred from your storage to the application server, your application server is sitting idle, right? And the processor will be underutilized here, right? So I mean, you need to look at ways how best you can utilize your processing, right? So your processor should not be sitting idle, like say 20 minutes, 30 minutes. So obviously you multiply that by so many servers, so much amount of you can say so many processors are idle for so much of time. I have a quick chat coming in. Okay, that's from RK. All right. Now the problem solved by Hadoop is what we talk about, right? Hadoop provides a solution: bring the data to the CPU and store the data locally, right? So what you're saying is you store the data where your processing is happening, right? So that's where we talk about taking the processing to the data where your data is being residing. Okay. Now, local storage on many disks is much faster than any NAS or SAN for the same cost. Okay, so you have we talk about huge number of clusters. When with Hadoop as a solution, we talk about clusters, right? So what is a cluster now? A cluster is made up of a number of nodes, right? It's a number of servers. Now each server would be having a disk space, and each server would be having a processing capacity. Now your storage is taken care by the individual disk space. Your processing capacity is taken care by the individual processor or the CPU resources. So this is what it says: local storage on many disks is much faster than on any NAS or SAN for the same cost. Okay. Now, how does Hadoop solve the problem? So Hadoop is reliable, it's linearly scalable, and low cost and high performance, right? So some of the important things you need to understand: what is reliability? Reliability is every data, all the data you are loading onto the cluster is replicated 3 times. Now say, just imagine or just visualize that you are uploading a 100 MB file. This 100 MB file would be copied into 3 times. Okay, in effect you are occupying 300 MB of the disk space on your cluster. Now say one of the server holding this 100 MB file is crashed. Okay, it's down. So even though this server is crashed, you will have 2 other copies available. Okay, that's how your reliability is achieved. Your fault tolerance is achieved there. Now second one is linearly scalable. Scalable is, now you have a 50-node cluster, and say, I mean, your cluster is about 1 petabyte scale. Now you need to add additional data into the cluster. What you do is simply invest in additional hardware, purchase a new server or purchase a new hardware of say about 1 terabyte or 2 terabyte disk space, add it into the cluster. So when you add a new hardware into the cluster, you don't need to restart your cluster. Right? You don't need to do any restarting. No process needs to be restarted. Nothing. Simply purchase a new hardware and tell to the master or tell to the cluster, this server will be part of your cluster going forward. So what will happen? You have in effect increased the capacity of your cluster without restarting anything. Okay, so this is something which is not possible or feasible with the earlier solutions, but here you can scale it, linearly scale, right? Linearly scalable is adding, that is your horizontal scaling, right? So there are two types of scaling. One is a vertical scaling and the second one is a horizontal scaling. So vertical scaling is limited to the, or you can say is bound by the motherboard capacity. Okay, you can only scale it up to a level where your motherboard supports. But linear scaling, yes, you can keep on adding as many nodes as you want into the cluster. Now the third part is commodity hardware. So commodity hardware is something which is cheaper, or you can say which is cheaply available. Okay, it's not cheaper hardware but cheaply available. Okay, not a cheaper hardware but cheaply available. In a sense, it's a cheap, not expensive like your enterprise class server. Right? If you want to invest in a server for the same amount of money, you can get a number of commodity hardwares, right? Different servers. So that is something which we'll talk about later, and I mean that's one of the reasons why people are looking at Hadoop as one of the best solutions. And the low cost and high performance again revolves around this commodity hardware. Low cost is because you are not investing in a huge enterprise class server, and also you're not paying any license here, right? It's an open source product which is available for anyone. Anyone can download it and set up their own cluster. You don't need to have any license for it. Yes, in case you want to have support for an application for your Hadoop cluster, if you want to have support from a third-party vendor like a Cloudera or Hortonworks, you need to pay for that. Okay, and high performance, right? High performance is what is achieved with when you have multiple nodes in the cluster. Right, obviously you'll have a huge performance. The more number of nodes are there in the cluster, the faster the response would be. Okay, so any questions so far, guys, until now, before I move on? So this is, basically this is how we talk about, and then we walk you through the core components, right? So I think we're short of time. Maybe I'll quickly do a demo part, and then I have something else to cover also. So this is how our, the theory part would be. Basically, we walk you through the core components. Okay, explain to you the theory, and then we'll show you the actual, we'll show you the demo part. Okay, so basically now the next logical step or the next thing would be obviously to cover Hadoop and the Hadoop components, right? So we talked about earlier with storage. Now with here the storage here would be your HDFS and the MapReduce. So don't worry about this terminology. This is something which you will be understanding as you do this course, or during the duration of this course. You will get to know this terminology and you'll get to know all the details. Right. So primarily the two important components we talk about is HDFS and MapReduce. Okay, HDFS is your storage area, and MapReduce is where your processing is happening. Right. So you store the data on the cluster, and what you do with the data, you need to process the data which is there on the cluster. So that will be taken care by your MapReduce processing. So MapReduce is again a Java program. Okay, Mapper is one program, and the reducer is one program. And in effect, whatever you submit on the cluster would be converted into a MapReduce program, right? So the entire master and a slave architecture. So you have a name node and we have slave nodes. So we talk about master slave or manager and a worker nodes, right? So where your master node is a primary driver, or is a guy who is actually controlling your entire cluster, and the slave nodes is where all your individual components or individual nodes individual servers will run. Okay, so this technology is all related to Hadoop 1. When we go to Hadoop 2, the technology will slightly change, and we also show you, we'll show you the differences between Hadoop 1 and 2, and in what areas Hadoop 2 has advantages in comparison with Hadoop 1. So this is what your cluster would look like. Okay, a picture from Yahoo's link. So your typical cluster would look like where you have your data center, right? So when you say Hadoop cluster, this is what your hardware would look like, right? This entire cluster. Now there are various modes of installation. The primary would be a standalone installation, only good for development, right? Only for development purpose. The second one is pseudo distributed mode. So this is what we'll start with. Okay, pseudo mode is where all the processes or everything you are running on a single machine. A single machine, you are replicating it as a big cluster, right? One machine you are setting up as a cluster, and that's what is pseudo distributed mode, right? That's a single node. Then the third one is a multi-node cluster. So we start off with a single node cluster and then build upon that. Okay, build upon what we have learned till that. Maybe I think in about class 3 or 4 where we talked about, we set up this machine, and then in our session 4 maybe we talk about installing a fully distributed cluster. Okay. So having said that, so this is something which we talk about, evolution of Hadoop 2, right? So we have Hadoop 1 here. Let me take just a minute. So Hadoop 1, we talk about Hadoop 1, and we'll also see why the problems with Hadoop 1, what are the problems with Hadoop 1, and what are the advantages with Hadoop 2, right? So, I mean, Hadoop has evolved over a period of time where they initially rolled out one version, and over a period of time they have learned some things where there are some disadvantages with Hadoop 1, and those disadvantages have been overcome with Hadoop 2. Primarily, the most important thing is introduction of YARN, which people would typically call as MR version 2, right? So here you have MapReduce, and your MapReduce is responsible for your job scheduling, resource management, and monitoring, where your resource management is in your Hadoop 2, your resource management has been segregated and taken separately. So that's where your entire capacity of the cluster is counted together. Okay, so this is how our theory part would look like. And coming to the demos, primarily the demos will be given on an EC2 instance. Okay, so if I log in here, I'll just walk you through the demo part on how we do the demos. So this is Linux-based environment. Everything is Linux-based. The demos are all done on Amazon EC2 instance, so that it's easier to set up. Okay, so there are other alternate ways for you to learn, but this is the easiest way and the quickest way to set up and learn. Okay, and this operating system that we install, right, is everything based on Ubuntu. Okay, so Ubuntu 12.4 is the version where we show all the practical demos and installations for you. Okay. Now, as per the Hadoop version, if I already have a Hadoop installed on this, so I'm just quickly giving you. So the Hadoop version that we have is about 5.33. Now there are various versions, right? I mean, there are various vendors available. So primarily you have a CDH. So what it is saying. So let's come back from the left side. So this is actually Hadoop 2.5. So Hadoop 2.5 is the core, right? So the core from Apache, your Apache project, your open source Apache project is what your Hadoop 2.5 is. Now there is something appended to here where it says CDH 5.3.3. Now what is the CDH 5.3.3? So what happens is Cloudera, so this is a version of Cloudera that I have downloaded, version from Cloudera that I have downloaded. Now Cloudera takes the same Apache Hadoop, okay, packages it, okay, I mean wraps it up with their own packages. Like say Impala is one application Cloudera provides, then there is a Hue which Cloudera provides. So they wrap it up with their own packages, nicely package it and give it to you as a single package. So what will happen for you in effect, if you purchase the license from Cloudera, you simply need to install the package from Cloudera, and that will take care of setting up everything for you. But if you go with the open source Apache, you need to download each of the packages individually. Like say your Hadoop, your HDFS and MapReduce. Then if you want to use Scoop, you need to download Scoop separately. If you want to use Pig, you need to download Pig. If you want to use Hive, you have to download Hive separately and configure them individually. But with CDH, or you can say, okay, let me explain this part also. CDH is Cloudera distribution including Hadoop. Okay, Cloudera distribution including Apache Hadoop, and that version is 5.3.3. The current version I think is 5.4. The version I have is 5.3. So that's why you say they call it as a CDH version. So this CDH version is a package of your entire all the components that you require. They will give you as a package, and out of them you install only what is required for you. Okay, and another important thing is they have given a nice GUI interface where from the admin interface you can simply do next, and I'll show you that also. So if I can log in here, right? So they call it as a Cloudera manager. Okay, so from the Cloudera manager you can see all the hosts, right? So here I have a 3-node cluster setup where in fact it's not completely set up. I was about to set up, so because of time's insufficiency I could not complete it. So here is where you can actually control your entire cluster from a Cloudera manager. So we will show you these steps how you set up via Cloudera manager. Okay, Cloudera manager is again an offering from Cloudera where a GUI admin interface from which you can install all your set up your cluster. Now similar to Cloudera manager, there is a HDP installation also. HDP is Hortonworks data platform. Now Hortonworks also provides a GUI interface that is called Ambari. Okay, that's again an open source project from Apache. So Ambari is something which Hortonworks would leverage, right? So Hortonworks, the look and feel slightly differs, but in effect what you're doing here or what all activities you can do is all the same, right? So we'll walk you through these 2 steps. Okay, we'll provide you guidance, or we'll provide you steps on how to install Cloudera manager. We'll provide you instructions on how to set up HDP or Ambari, and how you can come up with a cluster. Okay, you can spin up with a cluster. So simple here. If you want to add a new cluster, you can just click on new cluster. Okay, and if you want to add any other services, you can simply add those services from the GUI admin interface. So this is the practical oriented where we suggest you guys spend as much time on practicals as much possible, okay, because all the information will be provided to you. So the more time you spend on the practicals, the more details you get, and how you so these instances will be spin up and provided to you on your request. So based on your request, these instances will be given, and you can spin up or set up your cluster on these machines. The final part of my demo is on why Hadoop and why you guys are looking at it. So if you look at big data forecast, right? So you can see this is one of the IDC has provided this diagram. I think so. IDC is one of the leading consultants who does a lot of market research. So out of their research, what they say is, you can see the huge growth, right? There is a huge requirement of big data professionals right now. So US itself has a shortage of about 1 million people. So they need so many big data professionals, either be it administrators or developers or architects, or you can say analysts. Okay, there are multiple roles here, which we'll see in the next couple of slides, where these different kinds of roles are a requirement currently in the industry, and there is a huge breadth of people there. The future really looks good. A lot of people are investing in big data as a solution. I would say people have actually matured now. Companies, not people. The companies have actually matured now. Earlier they were actually looking at only developers. Now they are looking at people who can manage apart from development. They can also manage the admin stuff. Right? They can set up a cluster on their own. And they can write their code also. So that is something which people are looking right now, where people with various skill sets can fit into this role. A big landscape, right? A huge landscape on the infrastructure side. Different companies are using it, right? So it's crowded right now. A lot of companies are looking at Hadoop as a solution, and different day in and day out, you come up with one or the other solution. Okay, and these solutions will be obviously. Being on this industry, I think it's always good to learn. Okay, be on one step ahead as you get more details or more. As you add more tools onto your resume, it gives you more advantage. Now the job types I was talking about, the architect, and there's a developer, there are data scientists, and there is a Hadoop administrator, right? So an architect is someone who is responsible for your entire planning, right? So if there is a request comes in to a business unit, if some of your business units or a company says, I want to look at a solution, your architect is a guy who will actually drive this entire setup. So from the architect perspective, he's the guy who will choose what are the physical servers, what is the memory, what is the capacity of the cluster. Everything will be decided by the architect. So to be at the architect level, I would say you need to learn a lot, right? You need to know the deep in and out of you need to know about the application side, you need to know about how do you set up, and you also need to look at how much data is coming in, and you need to plan it, right? So plan and execute operations of organizations, big data operations. Now the development part, developer who does actual coding, right, for your Hadoop. So you have a business use case. Business use case would be communicated to the development team. The development team who is the one who writes the code, and when they write the code, they'll actually leverage the data which is available on your cluster. Okay, so a highly demanding role is a data scientist. Okay, which requires knowledge of both your business cases, use cases, and also how you run your cluster. Right. So a knowledge at the both levels is what right now the very huge demand, I would say, is a data scientist. Okay, data science is something which is picking up very rapidly, and it is coming up in a huge fashion now. Administrator, obviously the guy who sets up your administration, your cluster, responsible for setting up the cluster, managing, deploying, and doing any troubleshooting on your cluster side. So various different roles. Okay, so admin, you can choose, once you do this course, you can choose whichever path you would like to go. Either you want to be administrator or a developer, an architect, or data science, yes, would require a little bit of more effort from you, but this would be a stepping stone for you guys if you are looking at data sciences as a future goal. All right. So why with XcelFrameworks? I think we already explained about this, how this course is modeled around. Like people outside give you either admin or development or NoSQL, but here we are combining all these three together and providing you so that you can get to know all these three simultaneously. And if you look at this component, right? So here is where MongoDB and Cassandra is picking up right now. So basically Hadoop is where a lot of people are using right now, and this is all. On the NoSQL side, you have Cassandra and MongoDB widely being used now. That said, I would like to conclude here. And any questions you have around technical side, please let me know, and I will let Anthony take over from here. Well, you can type into the chat window if you have any questions. Please feel free to send it out. Okay, so if no questions coming in, Anthony, you're there? Anthony or Daniel? Okay, so I have a question coming in from Imran Raza. He's asking what is the difference between yarn and MapReduce. Okay, so I'll explain this here. Yeah, we'll talk about that in maybe in our class 3. I think we talk about yarn and MapReduce, right? So see, here with Hadoop 1, we're talking about MapReduce, right? So we talk about MapReduce, and MapReduce, as you do the course, you'll get to know what is the job tracker and what are the responsibilities of the job tracker. So job tracker is someone which does job scheduling and resource management and the monitoring. So it's a single guy, okay, who does the MapReduce processing, and the job tracker is overburdened. So we'll see how the overburden happens, because it's a single thread. Job tracker is a single process or a single thread, and this single thread will need to make sure your process is happening, right? So there is a job tracker concept and there is a task tracker. So job tracker will always be talking to the task tracker and making sure the task trackers are available. Now, if a task tracker is dead, it is again the job tracker's responsibility to make sure the task tracker is up. Okay, so job tracker should be responsible to accept the jobs. Okay, should be responsible to make sure to decide where the task can run, and also should be responsible to make sure the task is completed. Irrespective of if the task is failing, he need to make sure he distributes it to a different machine. Now with Hadoop 2, introduce Yarn. Yarn is yet another resource negotiator. So they have segregated the job tracker's responsibilities, right? So resource management part has been segregated and delegated to something called resource manager. Okay, there will be a resource manager and there will be a node manager. Now within resource manager, you will have a scheduler and applications manager, and on the node manager you will have an application container which will be dynamically generated when you submit the application, and there will be a container. So Yarn has reduced, right? Yarn will reduce the amount of burdens that has been there on your job tracker earlier. So the overburdens on the job tracker is reduced, is eliminated, and it will make sure that the job is completed. And the second thing is your entire capacity of the cluster is considered as one unit. Like say 100%, right? Earlier we talked about individual mappers and individual reducers, map reducers. How many maps you have on a single machine, how many reducers you have on a single machine. But with Yarn, you talk about the entire capacity cluster, like say 100% of the cluster. Now allocate 10% to one queue, allocate 20% to a different queue. So an application coming in from QA can run only up to that 10% allocated resources. Okay, and in effect, if there is no person submitting any jobs, he can use the entire cluster. So that's we need to go deeper inside, but for the top level, you can see Yarn is a higher version of MapReduce. Okay, you can say it has good features where your resource management has been segregated, and it is making sure that your cluster is effectively utilized, and overburdens on the job tracker has been eliminated. Okay, so any other questions, guys? Okay, perfect. All right. So Anthony, you can take over if you're there.
Yeah, Kumar, that was Dhiman's question. Can you just have that answer? Can you give specific examples of labs that we would be doing?
Okay, so specific examples of labs. Okay, so I can go back here now. Now, one of the important things coming to administration stuff is where you talk about multi-rack configuration, right? So normally when you set up a cluster, the cluster would constrain everything should be a single cluster. Now we'll show you the demos on how you can set up how you can do a rack configuration. Okay, there is something called rack topology. Okay, rack awareness, where when you enable rack topology, your data is distributed across the cluster equally. Okay, then we talk about high availability failover. Okay, so this is a lab practical where we say we can failover from, we initially set up HCL setup where we have two name nodes, that is with Hadoop 2. Okay, with Hadoop 2 you have a name node and a standby node, so you can do a manual failover and you can do an automatic failover also. So this is one of the other labs we can show you. Then there is a Kerberos setup. Kerberos is what primarily is used for security purposes. So we'll provide you on how to set up Kerberos and how you can authorize with Kerberos. There are other things like your NAGOS configuration, and you can also set up a Ganglia multi-node configuration. Then next labs, this is basically, obviously you need to install your cluster. Okay, we'll provide you a guide, the lab guide, where you will have to go through the guide and set up your, if I go here, I go to the classroom blog. I think classroom blog is what Daniel has showed earlier. So in that you'll have how to set up a CDH cluster, and you can also see how to set up a Hortonworks cluster. Okay, those are the lab practicals we show you. Then coming to the development aspects, we'll show you the instructions on setting up Scoop, right? So setting up Scoop, setting up Pig and Hive, how you install it, how you configure it, and how you run the real life examples also. Okay, so all this from an administration perspective will show you, we'll do it practically, and not only setting up, we'll also run the sample examples and real life cases, how you actually run your examples on your actual production cluster.